your fave one.
Oh, my favorite culture
Or
experience?
just everything you did.
Those are two very different things.
Everything you did.
What?
Everything you did.
Favorite thing that I did? Oh, I got really good.
Yours doesn't work anymore.
Who was gonna ask about?
We spent
Yours doesn't work anymore.
We got omakase, which is like chef's choice.
Yeah.
You just walk in there and they just make
Okay, let's cover a couple new topics here. So,
Yum.
so Nathan's not here. Gavin pulled his back. Connor's too good. Okay, so we did Fibonacci sequence. The Sierpinski's triangle. Did you guys? Anybody attempted to do this yet?
I read.
Read the statement. You wrote one letter. Okay. Yeah.
Okay, how fast is your computer doing it?
Pretty quick. Do you how fast is yours? Do it.
100,000 dots was 0.5
Isn't that crazy? Isn't that crazy?
If you initialize it,
Yeah. If you initialize it, and there's a huge
otherwise it takes forever.
huge difference, right? And so that's what I was trying to show was this initialization. Let me show you. I did this as an example today too. What's that?
Are those the new notes you put?
Yep. We'll get to those. All right. You guys ready? Is everybody ready? We ready to? Did you get yours working?
No.
Okay. You could go sit by Ciara over here.
I never looked at this one.
Oh, you always look at the other ones? Okay. So let me just show you, this is the initialization thing, right? This just to show you, right? I have it in the notes, but it maybe isn't clear what I did. So here it is. This is a very simple thing. Hey, Connor, how's it going?
Sorry, I got lost in the sauce.
You been drinking? Is that what you mean? Is that what you lost at the sauce means you've been drinking?
Oh, I meant like Tim's over.
Oh,
Yeah,
okay.
he's focused. He was being productive.
Hudson was drinking last night.
Huh?
Hudson was drinking last night.
What?
Catching strays over there, dude.
You don't drink while you're doing homework?
I'm working on the weekends, yeah.
So just to show you, I'm trying to teach class here. So this, all I do with this little section of code, I just say, I clear the variable a. I said my size is 1 times 10 to the 9th, right? And then this one, I initialize it. This is what I mean by initializing a variable. I just said a is a bunch of zeros, right? And the 0 is going to be, however, it's the size by 1. So it's just a vector that has 1 to the 9th elements, and it's just a 1 to the 9th elements. It's just a vector with 1 to the 9th elements, okay? And so I make that vector first, and so it knows how big it is. And so it allocates. So behind the scenes, hardware-wise, it allocates memory. It says you get a space. That's a big number, by the way, 1 to the 9th, right? Is that a billion?
Yeah.
Right? It says there's a billion, you get a billion spaces, and it allocates it, and then it runs. And then I don't know if I showed this before, the tick and the talk. Did I show you the tick and the talk? When I'm saying how long does something take, if you put a tick before and talk afterwards, it'll tell you how long it took between tick and talk. Okay, how much time? That's what the output will be, right? And so then all I do is I said I equals 1 to size, so 1 to the times 10, 1 to 1 times 10 to the 9th, and then I just shove in 12 times I into that location, right? Whatever. It's just doing something that does that. If I run that little snippet of code that you see right there, it does 1 billion iterations, and in this case, it took 1.41 seconds, okay, to do 1 billion calculations, which should blow your mind, right? That in 1.5 seconds. If I do the same calculation down here, but this time I don't initialize a. Oh, where the hell did MATLAB go? Nope, not that. Right, I don't initialize a, so I just commented out where I shoved in a bunch of zeros, and if I take that and I try to run it, right, you can see last time I ran it, it took 32 seconds. Okay, so if you're running your Sierpinski's triangle, right, and you're trying to do this, I would highly recommend you initialize your variables beforehand, right? It's a huge difference.
I tried it without initializing.
It bogs down.
Well, after 4 hours of letting my computer run, I quit.
It still was going. Yeah. Because what it's doing is, in this case, down here, right, the one that taken 32 seconds, and this obviously, I feel like 32 more than 32 seconds have passed, is it's starting out and it's saying, all right, A, you get 1 space. And then it goes, wait, nope, now you need 2 spaces. Nope, now you need 3 spaces, now you need 4 spaces, now you need 5, now you need 6. And so it's growing each time. And so it took 34 seconds that time. It reallocates memory every single time that it applies it. And that takes time, and that's not efficient, and it slows the whole thing down, right? A factor of 10 or a factor of 30, just about 30 difference, right? And so it makes a huge difference on your stuff. So, okay. So that was the initialization. I wanted to show you that. Okay. The next, and it's fun. Did you get yours to work?
Yeah.
Isn't it cool? And then you should go in, and then you should zoom in on stuff, right? If you zoom in, it just repeats that same pattern over and over and over until you get way in there, and then you'll see the individual points. But until then, it does that, and that's called a fractal. Fractal, which is just fun to say and not useful in civil engineering in any way, right? But just fun to implement and do. Okay. So the next thing I wanted to talk about was figure editing. Okay, and that's what I started doing this lately. Is I've been working with Chat and myself to put together. Sorry. I've been chatting with Chat and have been doing some work for me. And it was like, I'm making my notes a little bit more complete. And I was like, could you help me put this together? I want to talk about editing figures, and can you help me with this? And I coached it, and we went back and forth. It was, its first iteration wasn't as clean as this. Yeah, it's eggs. It's great.
Or good chicken.
Chicken salad sandwich. So I posted this on D2L. I'm just going to show you this. And this is honestly, when I was doing my dissertation, this is probably one of the things that was it's super helpful for me. One of the most helpful things is how do I edit and do things to my figures and make them look the way I want. Adjusting the font size and adjusting the axes labels and all this really cool stuff that I was able to do with my figures, and I just created a function that did all these things for me. And so every figure I have in my dissertation is put together exactly the same way, and that's where this figure editing stuff comes in. Okay, it gets a little confusing. Okay, so there's the idea behind it is whenever we were coding, and we created a figure, we never caught the figure. And by caught the figures, we never assigned it to a variable, right? God damn it, I don't want to see these. I'll show you these later.
Very aggressive today.
Yeah. So when I was, say if I was just doing a figure, right? I was going in like this, and I was saying, right, I call figure 1, right? And then I'd clear my figure, and then I'd set my x equals 0 to 1 to 10, and my y is equal to my x squared, right? And then I'd plot these. Plot x, y, right? We do that, and then that's it, right? So then I would get this plot. But note that I never set my figure equal to something. But I could if I wanted to. I could say this. I'll call this fig is equal to figure 1. Okay? And so now figure is a variable. And if I said, well, what is fig? We could look to see what fig is. And then you look over here. I'll put it underneath here so it lines up. Right? And so what it says figure is this. And if you can see that, it says figure is a bunch of properties. Okay? It doesn't have a name, but it has a color, and it has a position, and it has units, and you can actually look for all the properties that are available. Okay? And they show up down here. You can look to see what they are, right? These are all the things that you can change with that figure. So what these things are called, these are called the children of the figure, which is, it's just showing hierarchy, right? You have the adult up at the top, and then you have underneath it all the children. Okay? And you can go through and you can edit all these children. Okay, and so if I wanted to change the color of the axes, the color is red, green, blue. It's how many red, greens, and blues you have. And you could change that. And so how you change that is you could go, I can come down here, and I could say fig.color, right? That's how you do it. And actually, look, it gives you some help, right? Say see, it shows you all the things that you can change. So fig.color, and then I'll set that equal to 0, 0, 0, RGB, right? And then change the background color to black. 0, 0, 0 would be black. And so you can do all of your edits to your figure after you've put it together. Okay, and then like I said, you can see one of the other ones that popped up there was fig.children. There's even more. You can see what fig.children is. So fig.children right here has xlim. It has an axis is part of the figure, and that axis has an x limit, an x scale, a y scale, a grid line. Right? It has all of these other stuff underneath it. So there's this hierarchy of stuff that's going on in there. Okay, you can also store. You could also do this. Even the plot itself, I can call this h is equal to plot, and then that too becomes a property. Okay, and you can see what's in h, right? H is the same thing. It's like the structure, and it's got these different parameters underneath it. It's got color, it's got line style, it's got marker size. It has all those things. We've always played with those a little bit, but we haven't done it with this formatting scheme before. So if I could do this, I could say h dot color, right, is equal to, can I say red? Oh, look at that. And it changed the color of the plot, right? And so the plot you can catch as well. You can catch each little component of it. You can even catch the axes as well. The axes are different components. But you're right. But all of these things are underneath. Since figure is this whole thing, right? Everything underneath it is all part of it. So like if I looked under figure, I could look under figure, I could look under its child axes, I could look under its child axes, and I would find that plot, which is part of it, right? There's a hierarchy as it goes down, but you can also skip the hierarchy and go right to some of the components. And that's what this is trying to explain to you is right, there's this hierarchy. You got your figures, the root, and then you have axes as part of it, and then the plot within the axes is also something. And I can label the figure as something, I can label the axes as something, I could label the plot as something, and I can catch all of them. Those are called handles. They are called handles, the things that are controlling it. And then I can change stuff inside of the handles, okay? And then, this tells you how you go about it, and it has some nice little examples on how to adjust things inside of it, okay? Some key handle properties, the color and the position, and the X lim and the Y lim, and the X label and the Y label, and the grid and the color and line width. All of those things can be edited. Okay, and we did that before, but never we codified it, right? Where you could code it. You could just like code, and I'm going to change all these things and I do it this way instead of doing it the other way that we did it. It's a pretty clever way of doing it. Okay, you can also save figures as well, right? And give you the example. It's called save fig, right? And so if I come up here, my MATLAB, wherever that ended up, right? And I could say. I could say save fig, give it the file name, example, figure, and then I just put it in a PDF like that, and it should take that same figure. Oh. And what did I do wrong? Do I need to give it which figure it is? Line 19, argument must be a .fig file. Did MATLAB let me down? Save fig, my figure fig. Does it work? Oh, save as. Sorry.
You're forgetting.
It turns out I don't know how to read my own. Save as. Okay, and then look over there, just right there. It shows up in the current directory is where it shows up, right? And I just exported it and saved it as a PDF. And you could save it as a PNG file. You could save it as a JPEG file. You could save it as anything. You could also save the figure itself as a fig file, okay? Like this, .fig. So if I come right here, if I call that .fig, then it stores it like this. And then what's nice about it, you double click on that and it just brings up the figure in MATLAB. And so you could do everything with that. It's like when I was doing my dissertation, right? I did all these calculations, nonlinear finite element stuff, all this stuff that was going on. And at the end, I would say, I'm going to save this as a MATLAB figure. and I'm gonna save it as a PDF, and then so I could import the PDF, and then but sometime something would be wrong, and I'd be like, God, I need to change the axes, and I wouldn't have to run the whole analysis again since I had this figure, the .fig file. I could just go in, and once this gets loaded, I could do all the same. I could change the file type, I could change the size, line width, I could change the axes, I could change the labels, I could do everything with it, and then export it again as a PDF. Okay. Anyways, this whole idea of like having a handle with these parameters underneath it, and the way you access those those values underneath it is with the dot. So h.color, I can go in and change the color, or h.marker size, I can change the marker size. It's very common in MATLAB where you just have these handles that you catch. You can catch the plots and you can catch all sorts of stuff. Even too, like when you guys messed around with your legends. Remember how you're doing legends, and then your legends, they had to be in the order that you plotted, and if you didn't put them in that order, like how did you do, like what if I wanted a legend on the first thing I plotted and the fourth thing I plotted? Well, you can do that with handles, right? Let me show you this help legend. There's an argument for that. Oh, you can do it where you, see, that's if they do them in order. Where does it show you? You could give it the handles. You can give it the handles and do it in different, yeah, right here. That's what they do here. So they give this AX1, gives it the handles. It gives us the handles that you want to label, and then you put them in order of the handles that you gave it. So that's one way you can handle it. Handle it. That's how you can handle it, Sean. Is you can catch each one of those plots, and then when you feed it legend, you give each one of those plot handles in a vector, and then you can say what you want to label those. So if you had a bunch of different things, right? You can under there you can reverse your axes. You could change like under like one of the children in there is the direction that the axes are. You can move the axes from the top to the bottom. You can add an extra axis. I think you did that, didn't you, on your dissertation, MTS? You added a second axis that was in different units on the other, or one was shear and one was moment, right? And that's probably how you did it. It was potentially with handles. No, it's not how you do it. Well, you could have codified it in there. But that's it. And so this document, I think, actually is really good at just kind of going through and showing you, and then does an example at the end. And your homework, next week's homework, has you do this. It has you take and create like have you create a little function that edits your figures. I tell you how to edit each one, and then it saves it. And so that's what you're going to do, is use handles and stuff for that. And then you can see that we walk you through some examples here as well. And we, meaning ChatGPT and I. Isn't that cool? ChatGPT, I worked with it to put this document together, and then it does this. Like it did this. It made this little like side thing over to the side, because this is done in LaTeX, and you can say ChatGPT format this in LaTeX, and it formats in LaTeX, and part of that, it creates this environment, which is this MATLAB coding environment, and it comes through and it shows you what all the commands are. Those in blue are the commands that you're using, and then it even highlights it's pretty cool. You guys are unimpressed, but you should be impressed what this looks like. Let me show you what that's a coding language that ChatGPT put together. Not that one.
That's pretty impressive.
Thank you, Bryce. I should speak to you. So this is the coding language that it puts together, right? It first, gave me the output, and I said, well, can you put it in LaTeX format? And it does, and then it creates this environment. This is the environment it creates, right? Where it says this right here. It says when we go into this environment, we're gonna keep track of like what's a command and what's not a command in MATLAB, and just it's beautiful. You guys don't even need me anymore. You should just talk to ChatGPT to do all this stuff. It wrote this whole thing anyway. It's actually really good. I will say I had to coach it quite a bit to get to this state, but now you have that. You could use that, and when you go do your homework, you could do that. Okay. So the next thing I want to talk about, a little more interesting than just editing figures and saving figures, although that's probably what you would use the most in the real world, is this concept of recursion. So cool. It is so cool. Okay. A recursive function. Oh yeah. By the way, I put together notes for this, and by I mean ChatGPT and I, not just ChatGPT.
You put in the
I put in the input, and then it gave me some stuff I didn't like, and I was like, can you expand on this? And then it's like, sure. And then I was like, can you expand on that? And it's like, sure. And then I was like, can you give an example, but then make it like so that they could try the example themselves first? And it's like, sure. Okay, so what a recursive function does is a function that calls on itself. Is it useful in civil engineering? Hell no, right? Is it cool? And just a neat, well, see, there's Sierpinski's triangle, not useful in civil engineering. But also, I have to point out, if it was just me and I was doing useful stuff in civil engineering, I would just do structural engineering all the time, which, for our non-structure person, I've tried to keep it a little lighter, like let's just work on the coding stuff and make it applicable to everybody, right?
Really? That's why.
Yeah, because I was trying to track all sorts, and then I just get my own.
We can do actual civil engineering stuff.
I know, just not as good, but just not as well, Kayla. No, but anyways, but honestly, I get tired of just doing structural engineering stuff. So it's kind of fun to do stuff that's not useful in any way. But recursion, so cool. It's a function that calls on itself. So you call it, right? And then inside of it, it calls itself. And then you're like, well, how does that work, right? So let's show you an example. The famous example of doing this, they're notorious for creating infinite loops, right? Because if you don't have something to stop it, it'll just keep calling on itself, and then it's an infinite loop, right? But you have to have something that make it stop. And so in the recursion world, it's called the base case. So it'll just work its way down until it hits the base case, and then it'll come back out. It'll stop it from, it will stop calling itself once it hits the base case. And then then it'll start working its way back up, okay? And so a very famous one is taking a factorial of something. Same thing we did before, right? We did some examples where we took a factorial of something, okay? So here's the right? Base case and recursive case. So there's just an if statement in it. It's basically if in this case, it's gonna be if the number is equal to 1, we're gonna stop. Else, call on yourself with this modification to it, okay? And that's called the recursive case. So there's going to be just this little if statement in there. If a value is 1, be done with it. Else, keep going, keep calling itself, okay? And so then the benefits of it, it's very simple. You'll see the line of code. It's just a really short section of code that we're going to do, okay? And then sometimes it matches the way that it flows anyway. Challenges, it uses a lot of memory. So you'll see, I'll show you one play itself out. What happens is it'll back up. It'll say, all right, I can't do this calculation again. I'm gonna call on myself. And say, well, I can't do this one yet. I'm gonna call on myself. I can't do this one yet. I call on myself. And it keeps stacking up like that. And that takes memory every time it does it. And then finally it's gonna hit the base case, and then it's gonna unzip back up, and it's gonna come back up. But until it hits that, it uses a lot of memory. Coding is really simple, but it uses a lot of memory to do it, okay? Performance overhead, MATLAB's default limits. There's a limit. MATLAB will stop it at 500 iterations. So it knows that people create these infinite loops, and so it's going to stop at some point, okay? And so we're going to do this example of the recursive function. This is it for the code, okay? That's it. It's a function. Right? Actually, let me show you over here. Let me do it over here. You can do it. Let's do it together. You can do it together. Okay, this will have to be a .m file.
It has to be.
Yep, because it has to call. It has to call on itself. Could it be? It doesn't have to be. It could be a .lmx. I'm gonna do mine as .lmx. Okay, because we can define a function in there. Yep, it'll work. Yep, I think it'll work. So function. Okay, result is equal to my factorial recursion. I'll do that. And then it's going to take in n. It's a function. It returns result. We call on it with a command, my factorial recursion, and then we just give it n. How many numbers of these things are we going to do? Okay? And so we have to have the base case. And it's actually, you can make the base case just be if n equals 1. Right, so that's the base case. If n equals 1, the result will be equal to 1. Okay, so that's my base case. When n is equal to 1, result is going to be equal to 1. Else, okay, my result will be equal to n times my factorial recursion, right? We're going to call on ourselves n, but not n minus n, we're going to n minus 1. Okay, so it's going to say, all right, I'm going to call on this thing, but I'm going to multiply it by the recursion. I'm going to call on myself, my factorial recursion of n minus 1. Not just n this time, but n minus 1. Okay, and then I'm going to end it. And that's it. Okay, and then I can call on this. Right, so you look how simple that code is, and we'll dissect it in a second. We'll look to see what it's doing. Okay, my rector 5, right? And let's see if this sucker goes. What did it do? Immediately, it doesn't work. Error found. What did I do? Oh, I need to put an end. I need to put an end on my. Did everybody else's work?
Yes.
Yours works? Oh, look at this.
I'm in a .m file though.
Did it? Okay, it works. I just didn't I didn't end my function. Okay, so that is the right answer, right? So look how simple that code is. But dissecting I get lost in it. It blows my mind, Sean. Right? So let's look to see what it's doing. Okay, this is dissect it a little bit. Okay, so I'm gonna say in here, I'm gonna show what n is if I'm inside there. And I'm gonna show what n is right here, and then I'm gonna pause right here. Right? By adding the pause there, that means it's going to wait for us. Okay? I think this. I don't know how it works in a .m or .mlx. Oh yeah, there it is, right there. So it's showing. Okay, so let's see what happens here, right? So what happened is, so it's waiting for us. Okay, so it went into it, right? And my factorial recursion 5. So n is equal to 5. So then it comes in and says, hey, is n equal to 1? It's not. So it goes down to else, and then it displays n. N would be 5, right? So it displays 5. There's my 5 right there. Okay, so it displays it. Then it goes in and says, all right, call on my factorial recursion n minus 1. Okay, call on that. So now n is equal to 4, right? But it can't return anything into result yet because it called on itself. So now it goes into itself. So it just displayed, all it's done so far is it's displayed n equals 5, right? So then it's just, oh, there's 5. So then it calls on itself with n equals to 4. So then it comes back up and it's coming back down. It's coming down, n equals 4. It says equal 1. Nope. N equals 4. Shows us that n equals 4. Then calls on itself again. Okay, so now it still hasn't done the previous calculations should have been n times 4, but it hasn't done that yet because it still hasn't returned anything. And so then it comes back, it calls on itself with n equal to 3. Comes down, is n equal to 1? No. Displays n equals 3, goes down again. Okay, still hasn't done any calculations, calls on itself again with n equals 2, displays n equals 2, calls on itself again, now n equals 1, displays n, displays result is equal to 1, okay? Or I guess it doesn't display result there, okay? So then it made it through this one time, and then it pauses. So then now if I come down and I let it go again, now it just starts unzipping itself. Why does it not work? No, it didn't. Oh, I never show result. That's what it is. That's my problem. I need to show results. Let me just show that again. Okay, yep. Then it displays the result 1, then it just shows the result as 2, and then it goes the result as 6, then it does result as 24, and then it does one more time as result as 20. So do you see what I'm saying about how it backs up on itself? Like it keeps calling itself, and it goes n equals 5, 4, 3, 2, 1. Nothing's been returned yet, and so that's when I talk about being stacked. It just keeps calling itself, and it's just stacked, and there's a queue of things that have to happen. Right? We have to wait for the base case to return 1. Once the base case returns 1, then it can do this calculation and it stores it at n equals 2, or result equals 2. Then that returns result equals 2. So now it can do 2 times 3. Then it does the 6. Then it returns it one more time, times 4 is 24, and then it does it one more time, times 5, it gives 120. Anybody, this is fascinating.
How did you get it to display the results?
I just got rid of the semicolons after result.
Oh.
Yeah, I had a semicolon there, you couldn't see it, but it gets real. I always get lost. It's like the movie Inception, right?
Good movie.
Right? Does it blow your mind? Just deep, right? It's trippy because it keeps working its way. This is really what it's calling on itself, and you're going all these different layers, and so it goes all the way to the base, and then works its all the way back up. So it like goes in, and then it shoves its answer back up. And the first few times I ran it, it's so weird to me that it displays 5, 4, 3, 2, 1. To begin with, because it hasn't even done any of the calculations. All it's doing is just showing, it just shows that, goes to the next case, shows it, goes to the next case, shows it, goes to the next case, and now there's this big queue that has to happen. It gets all the way down to the bottom, then it starts unzipping. It's like, well, now I give you this, which means I can give you this, which means I can give you this, which means I can give you this, and then it returns the overall result. But that code, compared to the code that we had before, right, when we calculated factorials before, it was quite a bit longer. It was more complicated, our code for calculating factorials. But this one, money, right? And I did it right almost from the beginning, which is. Anybody else fascinated by recursion? MTS, you like it, right? Huh? Yeah, there you go. Noah, you like it? Well, guess what? You get to do it. You get to do it on your homework. You get to do a recursive function on your homework, right? It's really similar to this. I don't remember what it is. You could do like series, like the what was the series we did? We just did Fibonacci. You could do Fibonacci sequence. I don't think I did have you do that. I don't remember what I have you do on the homework, but it's something like this. So hopefully you were paying attention, Bryce. As you're working on your wood homework, as we're talking about sick ass recursion functions. Okay.
They are pretty cool.
Yeah, they're right. So let me show you this. This is what I did in my coding class. This is Towers of Hanoi. You guys ever heard of Towers of Hanoi?
Yeah.
It is. I'm gonna get it going.
What are the Towers of Hanoi?
The Towers of Hanoi. It's like you may have seen. You got like you have 3 pegs, and then you have the different size elements as they go up, and you have to take all of them from one peg, put them on another peg, but you can never put a big one on top of the small one.
Sure.
You have to go that way. You could solve the towers. You could solve the Towers of Hanoi problem with a recursive function. Okay, and so then that's what. So I'll show you. So this is.
It sounds like a physical thing.
Isn't math like sillier than sometimes the human brain just do it. You don't even need to know that.
So this is Towers 10. This is solved. This is it.
It graphs it.
Yeah.
Oh, that's clever. I like that.
This is how you would solve.
Something that'd be on like a TV, like reality.
Yeah.
Like game show.
Yeah, you're genius. Are you genius or you're not? It shows up in my Instagram feed a lot. It's like only genius could solve this problem, and then it's the Towers of Hanoi.
Over and over again.
Yeah, that's right. So you gotta take, and then you gotta restack them on the original one, and then you stack the next size, and you go back. And this is like this is 1,023 moves to solve this one. Yeah, because right, you gotta do it on every single one of these things. But this is solved with a recursive function
That you wrote?
that I wrote as part of my coding class when I was in. And to be honest, I looked at it and I was like, I don't know how the fuck I did this. I must have cheated because I don't understand. I don't understand how.
You've had this for years?
Yeah, I still got it.
Wow.
Yeah, I still got it. Yeah,
So you can put any number there, like
Any number
Towers
there.
100.
on any number. Let's go with the
And
big.
it already ran all the calculations.
It run. Yep.
in
The.
0.09 seconds.
Yep.
It's
How long
just
did it take when you had your original computer?
I don't know. Probably days, right? Back in the.
your brain.
Yeah, first of all, fuck you, Kayla. And second of all, I thought they're making fun of my age is what you were kind of poking at my age a little bit, right? Back when you had your.
You're the one that's
Yeah. Let's see if it does Towers 100. See if it'll. Yeah, that might be a bit much even for. Towers 20? Oh, that was easy.
Did you pick the colors?
I did. I did all that. Oh yeah, look at that. This could be a nice screensaver. just going on in the background. Totally useful in structural engineering.
That's a tower.
How many are there?
Like how
in
the
this one?
function
20.
every single time into a
We're gonna be here for that.
Good use of class.
Oh yeah,
No, you
yeah.
just bring this to like some meeting.
I'm using my class time. Be very efficient.
Oh.
I mean, I tried. Like I said, I tried studying my code a little bit, and I was like, I don't know. I don't know what I did. Let me show Hanoi. This is it right here. So this is moves, right? N, A, B, C. And then so if n equals 1, right, moves A, B. So there's my base case. Else, I move shit around like this, right? Else, I call on myself with n minus 1, and I basically, it looks like A, C, and B get changed around, and then C, B, A is the other set of moves, and then it calls on itself, and then it just keeps, that's
Where's
recursive.
the plotting in that?
That's a separate. It was separate.
Oh, okay.
Yeah,
I was
this
like,
just
that's
does
so
the.
tiny.
This keeps track of all the moves.
This is just the
And then there's another function that does all the plotting.
Okay.
Yep. And then the plotting ends up being big.
Because
And
it's technically 3 subplot or
Yep.
3 plots.
3. Yeah, that's.
Or is it all one since they're interacting with each other?
What did I do? H plot. That's what I did. By the way, look, you know you can do this too. You select something, and then you can right click on it and then open it. It's kind of nice if you have like sub M files and stuff like that. You can see figure, clear, pegs, delay, make recs, p moves. Look at me. I used a bunch of small things. I will say that my thing did not involve plotting it, but I went above and beyond and plotted because I was a huge nerd, right? I'm just sitting in there.
Cracked out on
Great Monster Energy drink, listen to my headphones over the ears.
Just like
Yeah, just, I bet I can make these things, I bet I can plot this. I bet I can change the colors. Oh yeah, look at that. I bet I can do this.
Unhinged. Like you are a menace.
But and that's why I am a professor instead of a real engineer. Right?
You would be putting your company in deficit.
Absolutely. I would be fired.
You would not make
I'd be
anyone
fired
any money.
immediately. Okay, so that's recursion, which is pretty, I think it's cool.
wait, you use recursion to make that.
To make that, yeah.
Just for the
To calculate the moves.
To move, yeah.
To moves. And then I use some other things to plot it afterwards. And so then again, same thing, right? This little thing talks about the benefits and the negatives of recursion and things of that nature, and then gives you an example. They did theirs a little bit different. They went all the way down to 0. Technically, they should go to 0, but you can actually not be at 0. You can actually go to 1 because 1 times 1 is 1, and so you could start at 1 for your factorial, but its base case was that. And then also, by the way, I graded the first 2 homeworks. I will say, a lot of you there's lots of ChatGPT. That's fine. But just make sure you're learning along the way. It's a real, I'll tell you this, whenever I see fprint f, I'm just like, you motherfucker. This is ChatGPT. You don't know how to use fprint f. Whatever you're talking, that's a Fortran code. For some reason,
Except I learned how to use it.
yeah, but now you know how to use it. So I think the F print, I think the F in there stands for Fortran. It's like a Fortran code, and it's yeah, and S print. It was S print F, dude.
It does.
It does, and that's fine. Again, I didn't dock you for doing it, Bryce. But just make sure you're learning along the way. Just make sure you're learning. It's just a way of like. I've never used in all my coding days. I've never used fprintf, but it's pleasant.
Okay, I have not used that in my code,
Yeah.
but if we don't know like some of the coding language, how are we supposed to learn this without?
The help function.
No, absolutely,
But
it's
even
fine.
like we don't even know like what codes to look up in the help function.
Agreed. And again, Kayla, I'm totally fine with it. Just make sure you're learning along the way. I'm leaving it to you. We're gonna be adults. And just make sure.
find out.
Yeah, I guess we will find out. We will find out. And the reason I want you to learn along the ways is because that's what we're supposed to do, right? We're trying to, right? It's like, because literally, I think you could take my PDF and strictly just put the PDF in and say, do this for me, and it'll do it. Is that correct, Bryce?
I didn't put PDF.
Oh, you didn't, but I think you can, and I think it'll even bring it out and say, here it is, and here's the code, and this is everything, and it'll do it right, and it's wonderful. With the exception, I think homework like 7 or something. ChatGPT couldn't do it, and that's when all these people came and started asking questions like, how do you do this? It's like, oh yeah, well, and that's fine. Again, because honestly, like for instance, like the leap year one. Confusing as hell. Yeah, put that shit into ChatGPT. Help me with this. But then come back and study it afterwards. Like, what did it do? Like, why did that work, right? And then, because you can imagine, like, really complex stuff it can't handle yet, right? And so, I don't know something's wrong here. There's something's wrong with that.
What does FPrint do?
FPrintf is just a way of displaying. Like, I always just say display something, but FPrintf is a way that you display it, and you could say how many decimal
Like in
points you
your
want.
Like else display, that kind of thing?
Yeah, it just pops up. Like, for instance, like this output would say, factorial of 5 is 120, is what the output of that of that code is. And so it's like displaying, but you could say how many decimal points you want. Like some of the coding, it's like coding language, FPrintf. It's like how many decimal places do you want? What size do you want? Like, stuff like that is what's put in that FPrintf thing. So.
Actually, I started doing that in class from the help before ChatGPT.
Okay.
told me to.
That's fine. And again, it's totally fine. I get it. I understand. Like you have this thing that does it. Like do it, but just be careful. Just be careful. Just make sure you're learning, so that when I test you on it, you can at least do like some basic stuff.
Do we know when that exam's gonna be yet?
Careful.
Yeah.
Said before spring break.
Yeah, but we'll do it before spring break, and so then there's some main things I still want to cover in MATLAB. I'm gonna cut it short a little bit this year because I do want to spend more time on MathCAD. Tim's making me do it because Tim, when he was my student back in the day, he loved MATLAB. He did a bunch of shit with MATLAB. He made animations for his structural dynamics stuff. He did all this really cool stuff. He drank the Kool-Aid, right? Like he loved it, right? But then now he's like, well, as a real engineer, I never use it. It's like, I don't give a shit. It was fun, right, Tim? Like it was fun to do. Like think about like you never used your stupid environmental engineering classes either, but you had to take them anyway. So let's, but you're not that kind of environmental engineer.
Not that stupid.
Yeah, you're not that. Yeah, but
He still works with concrete.
that's right. That's right.
Sucks.
to her
It
chagrin.
sucks.
Yeah.
It's killing all of my bacteria.
It does.
It
It's not.
ruined it
It's
last week.
Is it why does it kill all your bacteria?
Because it's a
very.
hostile
Yeah,
environment.
it's a hostile
pH.
environment. VPH
You
wise
guys know
stuff.
what that means.
I
but-
do.
I barely understand. I barely understand what it
It's
is.
very basic. As in like the pH.
I understand.
Because I do think like in terms of like the real world stuff, I agree. Like if you want something to really use, Excel is a huge thing that you're going to use a lot. And then also, I think MathCAD. Has anybody used MathCAD yet? Has anybody seen the MathCAD output? It's beautiful. Anybody like Will's homework problems?
I know, because Tim always posts Will's homework.
Because they're fucking beautiful, right? It's like your hand counts, but it like you see the whole equation and the output there, and it's units. Like you have to handle units. You can take PSF and multiply it by a foot, and it'll give you PLFs, and it'll even say PLF. Like it's cool. So I will teach you that eventually, and I'll teach you Amanda. Does everybody know Amanda McMurray? It's Amanda McMurray will teach you because I'm getting wise in my old age, and Amanda was looking for a professional paper topic, and I had her put together notes for how to use MathCAD because I don't know how to do it. So that's she put together a whole like week or two worth of introduction to MathCAD because she used it all the time, and just beautiful work. So
So can we do the same things in MATLAB? Like
no, kind of, maybe a little bit, not at all. How about that? I think the answer is exactly what I just said. It is a little bit of everything. Some programs are better at things. Some programs are, but like MATLAB, you can make it do all the same things. You can make it do all the same things, but it's not made for doing those things. But you can kind of like make it do it. Like we can make it do symbolic. We'll show you how to make it do symbolic, but it's not good at symbolic. But we can make it do it. Where MathCAD, you can make it do loops and things like that, but it's not really made for that, so it's not as good at doing that.
So we're doing like MATLAB up until the midterm, and then we're totally switching
Yep,
gears.
yep. Then we're gonna do MathCAD, and then I'm gonna show you some other programs too. I'm gonna show you R.
Yeah, no, I know that one.
We're not gonna do anything with it. I'm just gonna show it to you.
Why would
We're
we
gonna
use
show
R if we have MATLAB?
Yeah.
because it's statistics.
It's free.
And it's free.
You can use MATLAB as a statistics package.
Yeah.
Sure, it is free though.
It's free. It's free. The other language we're gonna look at is Python.
Great.
Again, free. A free program. So if for some reason you go into the real world and they don't have MATLAB, because MATLAB's expensive, because it's so awesome, but it's expensive, and you want to do some coding, you'll whip out Python. You should see some of the shit I made with Python. Oh, it's so, because again, that when we do Python, we're gonna do it with straight ChatGPT. You don't need to know anything, and you can just ChatGPT, I want to do this, and you just give it to, and it gives it. I made the coolest asteroid game just by in Python, just with commands, just saying like, I want it to do this, I'd like it to do this, I'd like it to do this, I'd like it to. Can you add this? Can you add that? So cool. It is cool. That's right. You can. You absolutely can. You can have it do that, right? And so, by the way, that's what our final project is do something really cool in a project, and
With any software.
whatever you want to do, with any software, with all ChatGPT if you wanted to, right? Like everything.
Just do something cool.
Are we having homeworks on the other programs?
No. Maybe. Survey. It's a survey class. It's a survey class. I will say I
I've
lied.
been gone for a while.
I lied. MathCAD will. We will do some MathCAD.
That's like a week of
Yeah.
math.
Hey, MTS, have those been refrigerated? Have you refrigerated those? Okay, good. Thank God. Because that's like the number one reason of food poisoning is egg salad sandwiches. I'm serious because the mayonnaise goes bad, right? So I just ate one. I don't want. Okay, good. If we all get sick tomorrow, it's freaking. Yeah. It's MTS.
Skip work tomorrow
Just MTS, you son of a bitch. So the things that I want to, I'm planning on. Yeah, we're on the list, by the way. The DEI list.
What does that mean?
Wasteful projects.
Knew we would be.
National Science
That's
Foundation.
also DEI.
Yeah, yeah, we made it.
Mean project.
Ted Cruz flagged one of our NSF projects as being wasteful and immoral, I believe is the words that he used. Yeah, because it's
Good thing I've got my own funding.
because it promotes DEI, wasteful DEI spending on this thing. Nowhere in that whole entire thing does it say
Yeah, I've read the
anything
whole thing.
about. They didn't read it, right? It pisses me off. It really pisses
About
me off.
DEI.
Yeah, because it like.
What is DEI?
Diversity, equity,
And inclusion. And so they're going through and they're like, you cannot spend, because the National Science Foundation, we have a National Science Foundation grant to look at biofilms cleaning plastic out of water,
Yeah.
out of watersheds, and then studying how that affects. Like if you put, and we could use it to repair walls and things like that. So if we get like
Engineered living material.
engineered living materials, so that if you put this like bugs in the wall and then you get a crack in the wall and those bugs can go in and repair it and stuff, there's this living system in the wall, and then like, can we develop like something that works like that? And then in there, under broader impacts, we say something about, there's some comment that says, because NSF requires you to have, or at least you used to require to have broader impacts, you would say something about like, how does this affect society? And we say, well, this will help, marginal groups that may have trouble anyway, and that's all it says. Just one thing we say, and then because we said marginal groups, we got flagged as wasteful DI spending. There's no budget spent on that at all. No, nothing. We're just saying, oh look, it'll affect everybody, and it'll affect these marginalized groups positively, and we get flagged for it. We still have the funding, but we'll see. We'll see if we get hacked or not, or chopped on the chopping block here. It is. What pisses me off is like they didn't read it. Like it's not about that in any way. It's called engineered living materials. There's nothing associated with it. Yet we get, and then there's 3,500 NSF projects that got flagged, and ours is one of them. How many of the other ones did they just mislabel just to drastically cut for no reason? It just
Doge, baby.
Doge.
Department of Doe.
Oh,
Do you
yeah,
know
yeah.
anything about politics?
Yeah. You didn't know what DEI was.
I don't know anything about politics. I'm just wondering.
Yeah, I don't. I avoid it altogether. It gives me anxiety.
Yeah, me
But
too.
it gets shoved in my face, for instance, like this particular case where we're like, you're flagged for being DEI. And it's like, how does this happen?
There's anti-science.
Anti-science. Oh, you were just talking, yeah.
Like earlier today, we were like, oh my god, it's going to shit.
Yeah.
Anyways.
Anyways,
Recursive.
recursive functions.
Yeah.
Let's get back to, this is way more fun to talk about, right? Recursive functions, they're cool. All right, so the next thing was, so things that I want to cover before we move on, right?
Recursive functions.
Structure arrays, well, we've already used those a little bit, but we'll talk about those a little bit, okay? The other thing I want to talk about, they're actually really powerful and work really well. And you've used them a little bit as well. Graphical user interfaces. I think we're going to spend a little bit of time with this. A lot of your projects that you put together, a lot of, at least they did last time I taught this, used a graphical user interface. That's my Gunner program had a graphical user interface, right? Instead of, like the games and stuff we made before where you input the numbers, like your homework, you're starting to make a Gunner file where you have to input the X or the velocity and the angle and stuff. This graphical user interface, we're going to insert like sliders and stuff like that to make these work. I use these in my dissertation a lot, right? Just for changing variables and stuff like that. And then we'll go over that and we'll do some examples with that. Anonymous functions, I'm not sure if we're going to do that. There's a bunch of like really powerful tools like differential equation solvers and zero solvers and solvers and minimum searches and maximum searches, but we might do these. I'm not sure. This is where ChatGPT couldn't handle it. It was a little too advanced for it, but we might cover that. That's one of the things I want to talk about. These are ODE solvers. You really have to trick it to get it to solve these differential equations. Stay tuned. Okay, stay tuned. Whether I can cover that. Symbolic toolbox, I will show you how to do that, right? So this is like, everything we're doing so far in MATLAB, everything has to be assigned, like X, if you ever call an X, it has to be numbers. Y has to be numbers. Z has to be numbers. Everything has to be numbers. But you can also have it solve things symbolically, where you just say, like, what is the derivative of sine? And it'll return cosine. Right? It won't, like we did that. We did derivatives on a numerical sense where we said, right, we're going to take the numerical derivative and all of the X's and Y's were known. And we took the numerical derivatives and the answer was cosine, like it looked like cosine, but it didn't tell us that it was cosine, right? Symbolic toolbox will let us do that. It'll solve it and it'll show us that it's that. And I'll show you how to use that because that actually is really helpful. Like, for example, even in your projectile motion problem where you had to solve for what Tmax was, and then you put that back in, you could use the symbolic toolbox to solve what that equation was for, or what it was. And then no, you wouldn't have made that mistake in your homework. You wouldn't have had the wrong Tmax equation. And did you see my comment? You didn't even look at it. So you look at it because I said, look, when we do, because you're going to use that same code in your future homework. So look at it. Your Tmax equation's wrong. That's why your graphs keep going. See, like they keep going down. They go past. But you could use the symbolic toolbox for solving that equation. Well, I'll show you that one. Data filtering, that actually is really helpful. I use that a lot in my studies. Right? If you have a bunch of noise, you could do these averaging and stuff like that. A lot of stuff built into it, into MATLAB to help you with that. I'll show you that one. Right? Cleaning up data, a bunch of like scatters like this and kind of like smoothing it out a little bit and fitting it. Object-oriented program, I'll tell you what it is, and then we'll go on. I think that might be it. Then MathCAD, yep. So not much more to do with MATLAB. I know you guys will miss it. Just when you're starting to learn it, right? I think you're starting to, right? The next few homeworks are intense, by the way, so make sure you're starting in time. You haven't turned in last week, he said, right?
I know. I forgot.
You're okay.
And then I went to New York, and I
No,
didn't think about
understandable.
And I do actually want to finish it
Okay.
instead of
I know,
hit it with the ChatGPT.
I mean, Chad will always do it.
You
I'll do it gladly.
oblige me.
Okay. Let's talk structure arrays. This is an advanced maneuver, but super helpful, right? So this is actually is really nice. Okay, you've seen them a couple times before. When we did tables, we used structures, right? When you said table read, and then it had like the different like fields underneath it, like what the headings were, what each one of the rows were, right? Those were the fields, like you used once before. Also the handles that we were using for figures just a few minutes ago when I was like h.children and h.axes and h.color. That's a structure. Those handles are structures, just meaning that it's like this parent over here, and then it has fields underneath it. Okay, and so you can make these things yourself, and they're really helpful. Just to show you here, so like this, I'd say variable x is 1 through 10, variable .y is x squared, variable .title is stuff. And then so if I said, well, what is variable? Well, it shows you right here. Variable now it has the fields, right? It's a structure array with fields x, y, and a title. And so it's really helpful to have those things. No, do you need new glasses? You're squinting though. Okay. You might go to the eye doctor. Check it out. Okay. I think you're just sitting over there just to make me, like, just to throw me off a little bit. Like, you got a TV right next to you, and then you're squinting at the little guy over there, and then you refuse to move. You're like, I'm not going to do it. So these are really helpful, because then you can also do this, right? So then if you go to plot it, you got variable.x and variable.y, and then I give the title of variable.title, right? And like look, see, x is a vector, y is a vector, and then the title is a string. So you could shove all sorts of stuff into this. So that variable now is carrying around an x, a y, so it's carrying around two vectors and a title, right? And a string, which is really, which is not as cool as recursion, but pretty cool that this thing's carrying around all of those things. And so when I want to plot it, it's like that. Because then you can also do something like this, where you can have multiple things under the same variable. Like I could do variable of 1, just like we did with vectors, right? A of 1, and like in spot 1 is going to be something. So variable in spot 1, I can have an x, variable 1.y, so I can have x and y's, and variable 1.title, so I have a title there. I can also, under the same variable here, I could shove in spot 2. This is spot 2. Spot 2, I can give it an x, a y, and a title, right? And so then if I say, well, what is the variable? Well, it has a 1x2 structure array that has an x, a y field, and a title. And then those titles could be all different, right? And so you can see how this would be helpful is if I went and I created a plot. I could say, all right, figure 2, CLF, for I equals 1 to the length of variable, plot x, y, and then give it a title inside of that thing. And so then it will go through and it'll put the titles on just with a loop. See how this would be helpful? So you just give it one thing and you can just loop through, and they all have the same fields, and you could run all sorts of plots with them and stuff. It ends up being super helpful when you're dealing with big lots of data. When you do that, it gives you an output like this. And so you have a homework problem where you use structure arrays as well, right? And it's just a way of like shoving multiple things into one thing, right? Works really well for when you have data sets or a bunch of items with similar properties. For example, like my research, that's right, my research, I had this column database, 500 columns, and all these columns had diameters, had reinforcing schemes, they had the area of steel, the strength of the steel that was used, the configuration of what the transverse reinforcement looked like, span lengths, different loading conditions. They all had that in this big, huge database. And they all had the same parameters. And so I just was able to I could just hand it over, say column 1, and then I know what all of its properties are. Column 2, I have all of its properties, all in these structure arrays. I did the whole thing with these structure arrays. Super helpful. And again, you used them once before when you did it with, table read, you used them. Yeah, structure arrays. How about you play with the structure array? Play with the structure array. Just give it a second. We got 10 minutes. We got 10 minutes. 4:20. 4:20. Just mess around with the structure array a little bit. No real things to do with it. Just like, right? I'm gonna A of 1. Say, call it whatever you want. You just put a dot afterwards to say, what is this thing going to be? It's A of 1, dot x position. A1 dot y position. Oh, you gotta set it equal to something. Equals 5 equals 6, right? And they say like, what is? And then you could say, what is A? Oh, I gotta clear A. Right, and after you run it, you got to see what's in it. It'll show you what it is. I mean, it tells you what it is. Right? It tells you, so, it's a structure array with these fields, right? And these are what their values are, right? And then again, you could in a second place, you could do the same thing. Right? So maybe the x position changed for the second one. Oh, I misspelled it. It's kind of new. When you look at it with the .mlx, it makes it nice and pretty. A1. What's really nice is just in one variable, you can shove all sorts of stuff. A2. They don't have to be the same sizes or anything. The more you code, you'll see. Like nowadays, when I code, I do everything with structure arrays, just because you can shove all sorts of stuff into a little file or into a little variable, vectors and things like that, and scalars and strings and titles, all sorts of stuff. What you do, you could plot something and grab some handles. You can work on your timber homework.
Thank you.
You try to plot something and grab some handles and see what's in there. Who's in there? Kyle?
Yeah.
What are you working on? Oh, you are?
Yeah.
There you go.
I'm still trying to get the line to stop when it hits the target. I got the target to move around.
But you gotta check each one.
Yeah.
You can put it in a loop. You can put it in a loop and check each dot individually, and then stop. Stop when it hits it.
Okay, so in the projectile motion.
Yeah.
Function.
Yeah. Yeah.
Because the way I've been trying to do it is I have the in range function stop when it gets true. So this one runs true, so when it gets to length of true, I was trying to get it to plot the path untip like through that number of.
So could you output, like you found that it was 3 that it stopped, right?
Yeah.
Over here you found 3.
Mm-hmm.
So your in range can output what point it stopped at.
I had.
Right, so like you know what I'm saying? Like your in range right now only returns yes or no, but you can have it return yes or no and the number where it hit. And so then when you feed it to like projectile motion, you only feed it through that point.
Let's see what I was trying to do here. Oh, I need to.
Yeah. You have stop, yeah. Just like that. So you're gonna output
And
the
then
stop.
it outputs.
Yep.
Stop is 3. I
Yep,
was trying
yep,
it that
and so
way
then-
and I couldn't get it.
So then
to-
where do you call on where it prints it? When it shows the plot?
Well, let's this is getting kind of messy because I've been trying a bunch of different
Because
stuff.
did you have
to see what
a
works.
projectile motion function? Is that what plots it?
Yeah. It's this function does the plot. But I've been trying to figure out how to kill just the one that hit. Like how to plot it through.
So basically, you could have the stop
hold on.
be like the total length. Because when it returns everything, like if it doesn't hit it, then
That's what I was gonna
stop
say.
stays the same, stays the total length.
That's what I was just about to add
Yeah.
is the else stop equals.
Yeah, else stop equals whatever the long is. And then when you come down to projectile motion, right, you give it an x, y, x range and y range.
Mhm.
What's the x range and y range? That's the.
That's just the to give you the
Oh, the
instruction.
target range. Like you could, where's the plot in here?
In a function. Oh, that's it. Because if
Can I see your thing again?
I had it working where it would plot until the one that hit
Yeah.
it.
Yeah.
But it would just plot all the way through. So
Yeah,
now
see
I'm
here,
trying to
see
play
here,
with
like horizontals and verticals, you just do, you could do, parentheses of the horizontals, and do one
Gives it a
through
stop.
and then verticals one through stop.
So it's it would be
Why did you get I?
one through that.
Whatever you would stop the.
Done. It will
Yeah,
input on
yeah,
the
yeah.
function.
50.
Because then let's say, because you found where that point is in the index, and then you've worked its way in, and so then
I
it just
think
plots
I
once
was
you're done.
trying that, but I was missing the if none of them are true. The
Yeah.
stop
Is the
was
last-
like nothing.
Yep. That should
Let's
do
see,
it.
does this return?
Oh,
See, you're drinking the Kool-Aid, Kyle.
Yeah, this is what I've been doing for most of
Yeah,
the
yeah.
Because it keeps getting like.
If you want
okay,
to,
this
too.
should work.
Yeah.
Yeah.
I have 2 more minutes. Technically 7 more minutes. Like if you're working on the homework and you have questions on the homework, this would be a perfect time to ask me about questions on the homework if you've started the homework.
The one that you just posted.
You typed your one letter. Do you need help with the other letters?
No, adequate.
The rest of them. The rest of the letters that
That's
you
so
need.
valid, actually.
I'm gonna stop.
Will you be around to help on the homework
Yes.
tomorrow?